So lots of times we have application problems that involve inequalities also. So here we have school carnival is going to charge $4.50 for adults and $3 for children, and the school needs to make at least $135 to cover their expenses. So A, we're going to use, let X be the adult ticket price and Y be the child ticket price. So we want to write and graph inequality for the amount the school makes on the ticket sales. And then B, if 25 child tickets are sold, how many adult tickets must be sold to cover their expenses? So to do this, then, we're going to, first of all, we're going to list the important information. What do we know that helps us? We have a story problem here, so what's going to help me accomplish my goal of getting these answer correctly? Bring enough for everybody? That wasn't my question. I don't have one. I'm not. It's from me? Yeah. Still got it in your pocket? No, it's in my bag. Okay. So we have two answers we're going to do. First, so we've got to write the inequality, graph it, and then find the rest, and then find out how many adult tickets to get there, cover their expenses. So we know the school sells the adult ticket for $4.50 and the children's for $3, and they got to make at least $135. All right. So what's the inequality going to look like here? What's the inequality that we're going to need that's going to have to be graphed? Number of people? There's going to be lots of people, adults and children. Okay. So it says, so we're letting X represent the number of adult tickets. Okay. Well, how much is each adult ticket worth? $4.50. So that means we'll say that 4.5X, because every X, or every adult ticket I sell, is worth $4.50. So if I sold 2 of them, I'd have $9. If I sold 4 of them, I'd have $18. If I sold 1, I'd make $4.50. Okay? Now, how else do they make money? Children's tickets, okay? And each one of them is worth $3 and exactly, okay? So if they sold 5 children's tickets, they would make $15. Okay? Now it says they want to make at least, so this represents how much money they're going to make. Okay? Because X represents how many adult tickets and Y represents how many child tickets. So this is going to tell me how much money we're going to make. Well, in this case, they want to make at least $135. Okay? So how do I represent at least with an inequality? Justin? Greater than or equal to. So that means then that I want this to be greater than or equal to 135. Because we've got how much money they make on the adult tickets, how much money they make on the children's tickets, and I want that to be at least $135. All right, so we're going to graph this. And if we graph this, do we need any negative values? No, because you can't sell negative adult tickets or negative children's tickets, right? Okay, it would probably be a negative if no one showed up. but that would still make them positive money and it would still be a positive ticket. Okay? So you have two options here. We can solve for y, okay, put it in slope-intercept form and graph it, or we could use intercepts to graph it. Probably in this case, the intercepts would probably be a little bit easier than solving for y. So let's find the intercepts. So to find the x-intercept, we'll let y equal 0. So we get 4.5x equals 135. So when we divide by 4.5, we get what? 30? Okay. You got 30? Okay, it's not 12. Okay. All right, and then the y-intercept. So 3y equal to 135. So y is equal to 45, right? Okay. So I will mark those on my graph. Oops. So my graph then, okay, if these are my intercepts, then my graph, I'm probably going to want to go a little higher than 30 on my x and a little higher than 45 on my y. And you can see that on my graph, I went from 0 to 50 in both of them. And by 5. So I've got my y-intercept is at 45, and my x-intercept is at 30. And I'll draw that line there. Now, does this line need to keep going in this case? No, because we're not going to have any negative values, right? Remember, we're talking about here, we're talking about when you do this, you need to make sure you label them also. This is adult tickets. Oops, if I can spell it right. And this is the children's tickets. Okay, make sure you label. Oh, I can't read that. There we go. Yes, sir.
How do you know that it's linear about the slope? I know it's straight.
Because I have an inequality in two variables. The variables are x and y. Do you see anything squared or any variable in the denominator or anything like that? No. Then that means it would be a straight line. Okay. Now, where will I shade in this? Will I shade above the line off to the right, or would I shade below the line down in the corner on the left? Well, they want to make at least $135, right? Okay. So it's probably going to be above. Is there a way we can check it? Okay. So we can check the origin, check 0, 0, see if that works. So if I put 0 in here for x and 0 in here for y, is 0 greater than or equal to 135? No. Okay. So then to finish my graph, then I will shade the area above the line, and I'm going to stay in the positives also. Okay? I'm staying in the positives because we can't have any negative tickets, right? Can't have any negative children's tickets or negative adult tickets. Alex, you all right with that?
Yeah.
Okay. All right. Just make sure that candy cane wasn't messing up your thought process. Okay. All right. So we've written our inequality and we've graphed it. That's the first thing they asked us to do. So this means that, okay, so let's talk about what this means. That means if I choose any number over here, any point, okay, that means it will satisfy my inequality. Okay? That if I put in here 30 adult tickets and 30 children's tickets, that they'll make at least $135 there. Okay? Also means that if I chose this point right here on the line, if they chose 10 adult tickets and 30 children's tickets, then they would make at least $135. Okay? Okay? Does everybody understand that?
How does that still, wait, so, oh, never mind.
That make at least, yep, the shaded part, okay? Anything on the line or in the shaded part is a region where any point inside that region answers the question correctly. Okay? All right, so then they asked us to do letter B. It says if 25 children's tickets are sold, how many adult tickets must be sold to cover the expenses? So we can actually answer this question two ways. We can put 25 in for Y and solve for X, or we could just go here get 25 for Y and over here to X, and oh, I can't figure out exactly what that one is, right, from my graph. Okay, so it looks like it's probably around 13 or 14, right? It's not quite 15. Okay. So I am going to have to solve it, aren't I? Okay. So we'll take our equation, our inequality. We're on part B now. And we'll put 25 in for Y and solve for X. Okay, we're trying to find out if there are 25 children's tickets sold, how many adult tickets need to be sold then. So we subtract 75, 4.5x equal or is greater than or equal to 60. So what's 60 divided by 4.5? 12. 13 point what? Okay. So 13 and a third probably, right? Okay, all right. So then that means that, so if their question is, 25 children's tickets are sold, how many adult tickets must be sold to cover the expenses? And so that means then that they would have to sell 14 or more children's tickets, right? Or adult tickets. So X would have to be greater than or equal to 14 for them to get it. Okay, does that make sense?